Hey guys, as promised, I am sending you another instructional video on more complex circuits. So Kirchhoff's loop rules and junction rules and all that sort of thing. Remember, a complex circuit is one where there is, goodness gracious, more than one battery. Okay, and I'm saying this is a more complex circuit because I added another branch, right? We'd only done ones where there were 1, 2, 3 branches before. Now there's a 4th branch. And really all that does is add more equations because there's more branches, therefore more currents. It's not really going to actually change how you approach the problem. It might make it, take a little bit longer to work out, and there's going to be more equations to throw into polysimul. But fundamentally, you're going to do the question exactly the same as any other complex circuit question. Okay, and again, remember the definition of complex circuit is one where you have two batteries not on the same branch, and therefore you can't, say, determine the equivalent resistance or something nice and simple like that. Okay, so the first thing that I'm going to do in this question is actually provide you with some values in case we, say, happen to need them. Let's say that the resistors are going to be 5 ohms, 10 ohms, all right, 15 ohms, 20 ohms. There they are. All right, and how about the batteries are 12 volts and 24 volts. All right, now the next thing that I'm going to do is what you would actually do when you were starting the problem, because obviously you'd already have numbers and such in there, right? And copy this question down somewhere. I think it would be helpful for you to work it out. And if you feel like you already have some idea of how you maybe ought to do this, then what you should probably do is pause me right now, work out the question, and then see if what I'm doing matches with what you're doing, and if we get answers that are, potentially in agreement. Okay, so the next thing that you ought to do is, the first thing that you ought to do is draw the currents. That's where you always are going to start with these questions. And then remember, currents always go from junction to junction. So you're not going to have a current like making, one big loop around like that. That absolutely is not going to happen, right? Rather, what you're going to have is, say, a current in this branch right here, starting at this junction and ending at that junction, right? It cannot just go through a junction because at a junction, that's where currents are going to come together or split apart. Maybe let's call that one I1. Okay. Next, I'll say current in this branch is going to be upwards, and we'll call that one I2. How about? Okay. This current, maybe downwards, and I3. Remember, we don't need to get any of these directions correct. I could be wrong on all of these, and as long as I'm doing my work consistently, I should actually still get all the correct answers. I'll just get negative signs in front of them, meaning I got the direction wrong. All right, and we'll call that one I4. All right, now sometimes getting the correct direction does make it easier. Like if you're saying it goes, from minus to plus through a battery, as I've done in every case here, that usually makes sense. That's probably how current is going to move, but not necessarily. It could go against a battery if you hook it up to a large enough opposing voltage source. Like if this 24-volt battery was 240, probably currents 1, 2, and 3 would all be downwards. Okay, anyway, enough about that. The hurdle that you're going to have to overcome is that, hey, actually, guess what? There were 2 sections of wire here and here where I didn't actually name what those currents are. Well, what do we do about that? And the first thing that you need to realize here is we don't actually need to know either of those currents. In fact, these 2 junctions could actually be the same junction, and it would not affect in any way the functioning of the circuit, meaning the spacing between this wire and this wire is unimportant. right? If I were building a parallel network here, which is what this all is, what I would probably actually do is just have, one connector right here in the middle, right? And so this wire would connect there, this wire would connect there, okay? And so really I've only got one junction right there. And even if I did say, well, there could be a current there, let's maybe call it I5 or something like that. If I did, what I would end up with is, well, I'll write a few equations, would have I5. Remember, that's that new current there. Let me maybe draw it. Okay, let's go there. There's I5. Okay, I don't know if that's the right direction. It's okay. We would say I5 and I2 are both going out of that junction. That one right there, right? Okay, and I1 is going into it. Okay, and then we would, for that matter, say at this next junction over here, I5 and I3 are both going in. So I5 and I3 go in, and I4 is going out. Now, if I add these two equations together, subtract those two equations from each other, what I'm going to end up getting is this. And I'll actually do that math in a moment, but here goes. We've got, if I'm saying that this junction, both of those two junctions there down at the bottom are really the same junction. And for that matter, these two at the top are the same junction. There they are. I should have drawn that in black. What am I doing? Anyway, those are the same junction. Then that means that the currents that are going into this junction would be I1 and I3. Alright, if that didn't make sense, you pause the video for a minute and look and see I1 and I3 are both going into that junction. So what I'm saying is I1 and I3 go into that particular junction there. And I2 and I4 are going out. If I were to subtract those two equations that I wrote just a moment ago from each other, check it and make sure that you follow this, right? But if you subtract those from each other, you're actually going to get this next equation that I wrote in red there, right? The I5s will cancel out, and you will end up with I1 on the left side and I3 also on the left side, and then I2 and I4 on the right side. In other words, we don't actually need to know I5. We can treat those two junctions as one junction and only have one current law, and therefore only four unknown currents, as opposed to ultimately 6, right? You'd say I5 down there, I6 up here. Oh no, 6 currents. So you'd end up with, say, like 3 different current laws and a lot of extra equations to throw into polysimul. No fun. Let's not do that. Okay, that actually is really the only one extra wrinkle that you have to add to this question over one where there were only 3 branches, is the fact that you can treat those 2 junctions as actually only being one junction, and you don't care about what the current is in that whatever length space in between them. Okay? From there, everything else would be writing your loop equations. So maybe I'll do a loop like this. Alright, so I'm going to go counterclockwise around that loop right there. Alright, so you would get 12, positive 12 because I followed the battery, minus 5I1, minus 10I2. Again, that's 12 minus 5I1, minus, because I followed the current. Remember, that's how resistors go. If you follow the current through the resistor, you get a voltage drop. All right, equals 0. It's an equal sign, I swear. Okay, and then maybe our next one will be, how about this? That's a great loop right there. So 12 minus 15I3 minus 10I2. I like that one just fine. Equals 0. Now let's pause for a moment. You might be thinking, I've got like 3 equations. How many do I need? How many do you need? The number of unknowns that you have, which would be 4. So we actually do need one more loop equation. All right, so our one more loop equation, how about we do this loop right here? Honestly, like as usual, you could do whatever loop you wanted to, just some are easier than others. So I could do this loop. I would say that's equally as easy as the one that I just picked there, right? And nothing wrong with this one. If you prefer that one, go for it. I could also do this one, which would be a harder loop, right? That one would go plus 24 minus 12, because I'm going against the battery, plus 10I2, because I'm going against the current through the resistor. Remember, that gives you an increase in volts, right? For resistors, it's did you follow it or not, and if you didn't follow the current through it, then it's a plus. All right, and then minus 20I4. I don't really want that one. So I'll go with 24 minus, what did I say, 15I3. And then minus 20I4 equals 0. Alright, I'm not especially interested, honestly, in the answers. You can work it out in polysimul and see what kind of an answer you get, and let me know. But what I'm mostly looking for is the setup, and honestly that's going to be true on the test as well. I'm not impressed by your ability to use a calculator app. Like, that's great, but what I really need to see isn't the answers so much as all this stuff and your diagram, which needs to match that work. Okay, that's the important bit that I'm looking for when I'm grading your work for these questions. Okay, if any part of that did not make sense, go back through, watch it again, right? But again, like, the only sort of key innovation there was recognizing that these supposedly two separate junctions could actually be the same junction, and thinking about them as being the same junction makes this question a whole lot simpler. Okay, if you need another example, look at example 13. That one's a little bit odd in that you actually did need to know one of those currents because there's a resistor in that section. Okay, but that's the only real quirk with that one. All right, hope that helps. Have a great evening or morning or whenever the heck you're watching this. Thanks. Bye.